Hello, we're back with chapter 19. Part 3, we're going to talk about how humans modify the beaches. And one of the things that happens is by various actions, we stop sand from moving. And one of the ways we do that is when we dam rivers. If we dam rivers or we change streams so they carry less sediment, and we talked about that a little bit before, if we reduce the sediment that comes into the water, then what happens is there's less sand to build beaches. So what happens is, if this keeps on happening, we basically, what they say, starve the beach full of sand, and beaches erode. Okay, and why is that a problem? Well, beaches are not only a great place to go and hang out; they're economically valuable, but they also are the first line of contact with waves in a storm. So when a hurricane comes in, larger beaches will absorb more storm surge. It's also a habitat for many animals. So it has lots of effects. Here's what happens. Here you have your normal, happy, everyday stream. Ain't hurting nobody, doing its own darn thing, dropping off sand here in this bay. And the longshore current takes that sand and deposits it over here and builds up this beach. Okay? But what happens if we change that? Now we built a big dam for free electricity to Las Vegas way over here. But what happens is, remember we talked about that? All the sediment in the water stops and is dropped there. So the water coming out here into the ocean has much less sediment. And what happens is all of that sediment that was getting dropped right here is now getting eroded because it's not as much as before. So now this side begins to wear away. So if we don't want beach erosion, what do? We can slow it down. There are techniques that work. One of them is called a groin. It's just basically a pier or a structure or a dock that sticks out right in the water. And it almost acts like parts of a comb. It helps slow the water down as it goes past it. And then that causes the water to drop its sand. So it kind of acts like a comb to catch sand in the water. A jetty is the same thing, but a jetty is built to keep the mouth of a harbor from covering up. And I'll show you what that means. And the last one is a seawall. So if you ever go to our lakefront, right, most of our lakefront, you have a big, huge concrete barrier and then rocks to the water. That's a seawall. We've basically hardened the entire shoreline and got rid of the beach. So one of the ways we measure this, how our beach is faring, is that we have teams of scientists go out with boats and divers, and they will actually go down in the water and take measurements. Here they're lining up all these. These things can be sighted by a laser from miles away, and they take a measurement to see if the beach is shrinking or growing. Here's a video camera just plain videoing. Here, it's interesting. You guys see that in the water. It looks like green. This is the same type of dye we use in Chicago to dye the Chicago River. Scientists put it right here in the water to track the movement. You can kind of see which way the wind is blowing the water. So let's get back to some of those pictures. I know it's kind of hard to see this one, but here we have some groins and some harbor entrance jetties. So the general longshore pattern you can see right here is blow this way. So it deposits sand here, and when it hits that jetty, it builds up, and you have deposited here. These jetties end in water that is so deep that it can't fill to the bottom and block it. So it keeps open this harbor entrance. If this wasn't here, right, it might cut that off and form a lagoon under the river behind it. Now over here, you notice, because there is no sand coming down here, it blocks the sand. There's much less of it. Erosion eats back the coastline here. So that's the problem. They have to be careful of that. It doesn't eat through. And then over here are groins, and you can see how they catch the sand. Here's some groins in France. I love saying that joke. It's not a joke, right? The water, so you kind of see how they kind of catch the sand. But I think I love showing this one. That these are the North Avenue groins. There's no other way to say that. Chicago's North Avenue groins. I like saying that. Here's Lakeshore Drive, right? If you're downtown, North Avenue Beach, you can see how these stick out into the water. Um, and the sand is coming this way, so coming from the north to the south, right? And these catch that sand and those fill in. Ironically, if you go there now, you can't, but if you were to drive down Lakeshore Drive, Lake Michigan is so high that these are almost underwater. So all of this land is covered. And I have a feeling when the water goes back down that these are going to be gone. They've been eroded away. So that's always an issue with Chicago's beaches. They're completely man-made. Here's a seawall. right? So they've taken this part of the coast and they've made it hard, bricks. It's not going to wear away. The waves will hit. And that was the thinking, but here's the problem. All this behind it, maybe there's sand back here. How does that get to the water to help build the beach? Because right now, I think they have access, like basically 50 tons of sand to build a beach, and a beach like this would probably take several million tons to replenish all the way. All right. We talked about sandy coast and beaches. The other opposite are rocky coasts. So if a coast isn't sandy, then it generally is rocky or rough. And I'm not talking about rocks on the beach. We're talking about cliffs going into the water. And the reason that we see this rocky coast, one of the differences is that the water is deeper closer to the beach, closer to the shoreline. So what happens is the water on a beach normally slows down. As it hits the bottom, that slows it down. But in a rocky coast, it comes in at full force. And so all that energy in the waves that we see when the waves break doesn't happen. And the energy in the water hits the coastline with its full force. And it actually breaks apart the rocks much quicker. There's a lot more physical weathering on a rocky coast. It's relentless and very strong and forms some really interesting things. I'm going to just put these terms up: sea stack, wave cut, knot cut, and marine terrace. Know that you can go back and look at these, but let me show you what they look like. This is a sea stack. It's like a chimney sticking out of the water. Usually with a sea stack you might find an arch. Something over here, this part of the land used to be out in the water much deeper, cliff face, and it broke away over time. Over time it eroded and collapsed into the water and formed these two features. But that is a headland. This is water that sticks out into the water. And then if you looked at a map, it sticks way out. Let me show you. This is the headland. See, it sticks out in the water. Here's another headland. In between the headlands are bays. So those are embayments. Okay. So again, let's go back to the image. Right, you've got a headland, and a headland, and a headland, and these small beaches in between. The rock here probably was just much harder to weather than it was here, so it gets cut into. Another thing you'll see are these beaches right here, and maybe sometimes in these rocks you might see caves carved out of the water, sea caves. Sometimes they're flooded, sometimes they're not, but they're always very huge. And it's a path for water to get into the building or into the rock face and cause even more structural damage. Next two are kind of interesting. You're not going to see too much of it, but the notch cut. So right here, the rock here, right above the water, is much more easily erodible than the rock above it. It cuts almost like a pedestal right here in the water.